Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on the topic application of dimension, which comes in the chapter units and dimensions. This is part 2 of the video. This is the first problem. It is saying the position of a particle at time t is given by the relation. They have given one relation xt is equal to v naught by alpha, okay, into 1 minus e to the power of minus alpha t, right? Okay, where v naught is a constant and alpha is greater than 0. The dimensions of v naught and alpha are respectively. Okay, now this is what this term is, what dimensionless. Yes. Wherever you see, okay, sine function, okay, sine function, cosine function, exponential function, these are all what dimensionless. Okay, these are all dimensionless. Okay, and even exponent, this is called what exponent, this is called exponential. Okay, this is called exponent, is also what dimensionless. This is also what exponent, this is called exponent. This is also what dimensionless. Okay, for example, if I write sine of theta, okay, sine is dimensionless, and this theta is also what dimensionless. Similarly here e is what dimensionless, raised to the power, that is exponent, is also what dimensionless. Means to say whose dimensions are equal to m to the power of 0, l to the power of 0, m to the power of 0, l to the power of 0, and t to the power of 0. That means, okay, this whole thing is equal to 1, not 0. Okay, you should not equate that to 0. Means to say that here alpha t, okay, we can neglect this minus sign, alpha t is equal to 1. Dimensionless means what? Alpha t is equal to 1. So what are the dimensions of alpha then? That is 1 by t, t to the power of minus 1, t to the power of minus 1. Okay, now because alpha t is dimensionless, that is equal to what? I am equating that with what? M to the power of 0, l to the power of 0, t to the power of 0, that is equal to 1. Okay, therefore 1 by time, that is t to the power of minus 1. Okay, now we came to know that what are the dimensions of alpha, t to the power of minus 1. Here also it is there, here also it is there. We will see which is the correct one. Now v naught, what are the dimensions of dimension of x? If this is dimensionless, dimension of x is equal to what? Dimension of what? This quantity, that is v naught by alpha. Okay, now we came to know what is dimension of x, that is equal to dimension of v naught by alpha. What is x there? X is what? Position. Position means that you have to use, okay, I can use this as L here, okay, that is equal to dimensions of v naught we are supposed to calculate, we don't know, divided by how much is alpha to the power of t to the power of minus 1. There from here I can calculate the dimensions of v naught, that is equal to what? L t to the power of minus 1. So we came to know dimensions of v naught are L t to the power of minus 1, right? Okay, and dimensions of alpha is t to the power of, this is the correct answer, because this is dimension of what? This is dimension of what? V naught. And what is dimension of alpha is t to the power of minus 1. Hope you understood this one. This is the correct answer. Okay, this is the thing that you have to learn. Okay, this is what? Dimensionless quantity. Whenever you have sine function, cosine function, exponential function, these are all dimensionless. Okay, even exponential function is dimensionless. Exponent is also what? Dimensionless. Like how sine is dimensionless and even theta is also dimensionless. Same thing. Okay, that is cos of theta. Cos is dimensionless. Theta, whatever there inside here, inside the bracket attached to cos, that is also a what? Dimensionless. Hope you understood this. We will go to the next problem. What it is saying here? It is saying that number of particles is given by n is equal to what? Minus d. n2 minus n1 divided by x2 minus x1. Okay. Crossing a unit area perpendicular to x-axis in unit time. Okay. Where n1 and n2 are number of particles per unit per, per unit volume for the value of x meant to x2 and x1. Find the dimensions of t. Okay. Now what is n? N is equal to number of particles here crossing a unit area, crossing per unit area per unit time, that is okay, into time, that is equal to what are the dimensions of this n number of particles, that is 1. Okay, that is equal to 1 by what, that is I can write 1 by L square, area means L square T. Okay, and if I bring this to the numerator, L to the power of minus 2, T to the power of minus 1 are the dimensions of n. We'll see what are n1 and n2. n1 and n2 is equal to what? Here they have given are number of particles per unit volume, Okay, we can write number of particles per unit volume. Okay, per unit volume means number of particles by volume, that is equal to 1 divided by, I can write what, L to the power of 3. So what are the dimensions of n1 and n2? That is same, that is equal to L to the power of minus 3. Okay, now what we are supposed to calculate, what is x? See, this is what distance, x2 and x1, this is distance or length. Okay, I can write the dimensions of x1 and x2 is equal to what, just L, right? Now from here you can calculate dimensions of d. Always neglect what, if negative is there you have to neglect in dimensions, that is not constant, and negatives are neglected. Okay, now that is equal to dimensions of n. What is n? N is what are dimensions, I will write here. Dimensions of n is what, L to the power of minus 2, T to the power of minus 1, that is equal to dimensions of d we are supposed to calculate. And what are the dimensions of n1 and n2? That is L to the power of minus 3, okay, divided by dimension of x1 and x2 is L. From here you can simplify. Dimensions of d is equal to, this gets multiplied, okay, L to the power of minus 2, T to the power of minus 1 into L divided by, what will be there? Divided by L to the power of minus 3. Cross multiply, okay. Now I can just simplify this to what? T is equal to L minus 2 minus 1 minus 1 plus 3, that is L square. T to the power of minus 1 are the dimensions of T. Okay, and m is also given here, m. Okay, m0. Okay, m0 L square T to the power of minus 1. m0 L square T to the power of minus 1. This is the right answer. Okay, dimensions of D are m0 L to the power of 2 T to the power of minus 1 is correct answer. Hope you understood this, students. Let us go to the next problem. What is this? The potential energy of a particle varies with distance x, okay, whose dimension will be L, from a fixed origin, as u is equal to what? U is equal to a root of x divided by what? X square plus b. Here the dimensions of x square should be equal to what? Dimensions of x square should be equal to what? Dimensions of b, that is equal to x is what? X is distance, that is L square. Okay, that is L square. Hope you understood. Okay, you are supposed to calculate a and b. Okay, where any be a dimensional constant, then dimensional formula for AB. Okay, you have to find the product here. You have to find the product here. Okay, now what is U? U is potential energy. What is the formula for energy? Energy is equal to what? Whether it is kinetic energy or potential energy, what capacity to do work, that is capacity to do work, that is work done, right? That is equal to what is work done? Force into displacement. Force into displacement. Correct. This we have seen in the previous video also. Force into displacement. What is force? Mass into acceleration. Okay. Mass into acceleration into displacement. That is what are dimensions of mass? M. Acceleration is what? Acceleration is equal to dimensions of velocity n to the power of t minus 1. What is velocity? Distance by time. It is speed by time divided by t. That is equal to L t to the power of minus 2. Okay, here. So ml t to the power of minus 2 again into L. Displacement is L. Therefore, m L square t to the power of minus 2. Okay, energy, that is dimensions of u I can write here. Okay, now dimensions of u you got, that is m L square t to the power of minus 2 is equal to a we do not know, right? And what is x? X is again distant. What are the dimensions of x? Dimensions of x, if x square is L square, x is what? L itself, right? Okay, so L to the power of what is root of x? Root of x is nothing but what? X to the power of 1 by 2, right? Okay, I can write this as what? L to the power of 1 by 2. Dimensions of x is L divided by x square is how much? X square is, that is L square. Now from here we can calculate dimensions of A. What are the dimensions of A? That is equal to m L square t to the power of minus 2 into L square divided by L to the power of half. L to the power of half. Now A is equal to m will be as it is, t to the power of minus 2 will be as it is, okay, because nobody is here to disturb it. M to the power of 1, okay, t to the power of minus 2. What is L? 2 plus 2 is 4, okay, 4 minus 1 by 2, okay, 4 minus 1 by 2, how much? 4 minus of 1 by 2, that is equal to 8 minus 1 by 2, that is equal to 7 by 2, okay, L to the power of 7 by 2, L to the power of 7 by 2, okay. These are the dimensions of A. Now what you're supposed to calculate? Dimensional formula for A and B. Okay, they are asking A, B, okay. Now let us multiply this A into B, right? Okay, that is equal to A is how much? M L to the power of 7 by 2 t to the power of minus 2 into what is B? Dimensions of B is same as x square, that is L, that is equal to, no term is there to disturb, m and t, okay, m will be as it is, t to the power of minus 2 will be as it is. Now here I can add up, okay, the powers. 7 by 2 plus 2 is how much? That is 2, 7 plus 2 2 is 4. If I take the LCM 2, that is 11 by 2. M to the power of 11 by 2 is the right answer. Okay, these are the dimensions of the product A and B. Okay, where m L to the power of 11 by 2, t to the power of minus 2. Okay, m L to the power of 11 by 2, right, and t to the power of, this is the right answer. M L to the power of 11 by 2, t to the power of minus 2. Students, hope you understood these problems. If you like this video, kindly share with your friends. Do not forget to subscribe from my channel and don't hesitate to ask any doubts in the comment box and like the video. Thanks for watching this video. I wish you all the best for your KCET, NEET and IIT JEE examinations. Thank you.